Okay, in this video we are going to attach all our motors for our control board. So to our ESC. So let's apply flux. Probably too much in my case, but you can do not so much in fact. And we are going to add solder to all motor wire locations. And let's do this. And pay attention that I already changed the tip to make sure that it's not so big, and as always I covered the board itself. So we are going to start adding solder. Not the most complex task. I believe the most complex one, it was soldering power cables that we already completed. Add enough solder to make sure that your wire will be able to go inside the bulb later and generate a solid connection between the plate and between the wire itself. Let's do this again and add flux and start adding solder. If your tip is too small, you will be able to see that your solder just go and stick to the tip itself, or then to the plate that you're going to attach your motor, and it will be really hard to even distribute your solder across these locations. So done. And we have to start attaching these cables. And there is a trick. Obviously, we will need to cut the cables, but we need to understand how we are going to attach them. You probably would like to attach like this, yeah? So to make sure that you can solder your cable, then it lies perpendicular to the board edge. It's not the right direction. It can be done, but in this case you have too many cables like this. And what it means that then you even trying to carry your drone, all these cables will not help you to do this. And you moreover, if you would like to attach some payload to this drone, and imagine you don't have any special device underneath in order to attach the payload, you probably can use just scotch in order to attach payload and fly. But if you have cables like this, they will not allow you to do this. And that's why we don't recommend to attach cables in this direction. It's better to lay all your cables in the direction of the arm, and after that attach it to these pins in a way then it's not moving too far outside of the drone. Especially in case of Mark IV version 2, then you know this frame is not too wide even to accommodate the flight controller. So that's why we are going to do like this. What we need to do, we need to make sure that this cable does not touch this bolt and potentially spacing that we are going to add to this bolt, because we would like to avoid a situation then these cables will affect flight controller and then potentially additional vibration and affect navigation capabilities. So let's do something like this, and let's cut the cable at the end. Let's measure, imagine, at the end of the first plate. We can cut this cable right here, And pay attention that I'm using cable that will be probably closest to this plate, not cable in the middle, not cable that it's lying far away, because later it will be really hard to attach this cable, imagine, to the third connection point here. So we are going to use them one by one, starting from left, and after that middle, and after that right one. And let's cut it. Do it very careful. If you're not sure, probably leave a little bit more, and later you'll be able to cut more if you believe that it's like too long. But if you make it very short, you will have generate tension, and it will affect your flight controller as well. So we're not going to do anything like this. And first cable, and the second one, let's do the same. So we are going to place it like this and cut it here. It should be longer, obviously, because we are going to connect it to the second connection point. And let's do some rotations. The same here. And third one is going to be like this. Okay, we'll cut it here. It's probably going to be the longest one. The same here. Prior to cut any cables, train your skills to use a cutter like this, for example, in order to cut just insulation rather than the cable itself. Because if you suddenly cut it, you will not be able to make it long after that. Yeah, so let's add flux and some additional rotations. Let's add flux, and let's add solder to end of these cables. Okay, and let's go one by one. Clean the tip, apply solder to the end of the tip, and let's start applying it to the cable. Make sure that it's everywhere, and you'll be able to build good connection point. Okay. Okay. Add a little bit more flux. And connect them one by one as we discussed. So first one we'll connect this one, and just you can apply a little bit solder to the tip and try to create a perfect bulb here. So you can see it's just like bulb that covers the whole plate and just generate a really solid body with the plate all together. Let's do it for the second cable. Let's attach it like this. Okay. And let's do it for the third one. Like this. Okay. So you can see we are moving each cable are moving on top of previous one, and once you start carry your drone like this, or once you start applying some scotch in order to attach any kind of payload, now your cables are not going to be affected much. Moreover, they should not generate any tension, yeah, so we just ice perfectly here, and it's probably the best way how you can attach your cable to the controller. In some cases, some drones have much wider frame in this area, and in this case probably it's not so important how you attach these cables, but for this one it's more important. And now I'm going to attach all other motors, and pay special attention that in order to make sure that you don't mix cables, and in order to make sure that you can measure length of the cable in the right way, attach them to the frame using ties first, and after that start cut them and start to solder all the cables. So done. Now you can use magnifier in order to check all the bulbs and make sure that everything looks perfect. And important thing, obviously you saw that we added much flux and we need to clean the board. Now it's so not easy as before because we already attached our board to the motor frame. And we have all these bolts here, stands, but let's do everything as best as possible. And I told you that it's better to clean power cables right after you attach them, because now you can see it's not easy anymore, yeah, so. But I already did it, so I don't care much about them. And check once again, in case of if you suddenly have any kind of shortcuts and find that you need to resolder it. Very important to make sure that you don't remove too much insulation. Just remove a bit in order to make sure that you can connect your cable to the plate, because if you remove much insulation, you can imagine that you can potentially generate shortcut because two wires, yeah, since you are putting one wire above another wire, so this if there is no insulation, it will be like some sort of shortcut and your drone will not fly. Probably will not have like smoke, but it will not fly because it will send drone commands to write to your motor. And I hope that everything looks fine. Check everything very careful. Make sure that you don't have. Make sure that you don't have bulbs, because you can see this one is big enough. As for me, probably we could do it smaller, but I see that it's separated. Yeah, I just covered exactly that point that we needed, and there is no contacts between this bulb and like another one. So everything should be fine. Everything should be fine. And now what we are going to do? Two ways. We can potentially attach other components to our drone. You can see now we can carry it like this. We can use scotch, as I mentioned before. We can attach camera, we can attach VTX, or we can try to set up this flight controller. And as I mentioned, we need to add something, some additional spacings if you have, or you can potentially attach plastic bolts. So in fact, I need to add some spacings, and I have some of these spacings, and I can do this, but assuming that you don't. So I'm going to attach plastic nuts, and it will add additional space between my ESC and my flight controller. And don't tie it, just make sure that it touches the board, and additional space even important for ventilation, because your ESC can easily reach temperature 100 degrees by Celsius, 120. If you have 120, 140, probably it's better to cut off the electricity and make sure that your drone will drop right away rather than blow and generate some fire somewhere in the air and probably fall down after that into a house or anything like this. Yeah, so that's why always set up maximum temperature, and in many cases, if something happening to the drone, the best solution will be just drop it. So now let's attach the flight controller, and you can see we have enough space to add additional plastic bolts on top. Don't tie, make sure that it can be moved a little bit, because it will help us to reduce effect from external vibrations. That's why I'm just add a little tension, but not much, and you can see it's movable a little bit. That's why if you add spacings rather than plastic bolts in the middle, in fact you can move it a little bit even better. You have like more space to move, and you don't have any fixed elements between flight controller and between your ESC, but we added plastic bolts, so, and our spacing not huge. That's why it's moving a little bit. It's enough. It's enough. It potentially decrease vibration. Okay, let's leave as is. Make sure that all these cables are moving into the same direction, and you did not leave some cables underneath and some cables outside of your space between ESC and flight controller. And now what we can do, we can attach VTX, we can attach camera, or we can set up ESC. Let's set up ESC first. Let's look at how we can update our firmware for ESC and how we can set up some basic parameters. Why I'm doing this? Because even now you can have some shortcuts and you can have some problems with your motors, and I probably can save time later if I attach all the components and found that nothing works because I have problem with motors. So even prior to test anything, I would like to attach smoke stopper, and let's attach the battery to make sure that we don't have smoke anywhere. Okay, and you saw that motors produce some sound, and all of them moved a little bit even. It's a good sign. It means that probably all of them have power and no issues with the motor controller with ESC. And let's go ahead and let's update firmware. And in order to update firmware, we will need to connect our flight controller to the computer, and we will need battery as well, because we will not be able to manage our motors with no battery. Okay, now we are ready to connect our drone to the computer. Let's do this and make sure that if you're using Betafly, that it's closed. So port that we are going to use in order to refresh our ESC, not going to be locked in this case. And next, we are going to navigate to the portal called AM32.k. AM32 is a firmware version that we are using for this ESC. And you can see lots of different kind of firmwares and ESCs on the market. The most popular is Bill-Haley for 8-bit controllers, and it's very old, and in fact it can be updated to BlueJ one, and you can see some Bill-Haley 32 controllers as well in the market. Bill-Haley 32 was not open source software, it was closed software, and now a company that supported Bill-Haley 32 announced that we're not going to support it anymore, and it's closed project. So don't buy any motor controllers, don't buy any ESCs if you can see that way based on Bill-Haley 32. AM32 probably the most advanced and latest version of the firmware, and we are using it here. It was pre-installed, and what we need to do, we just need to read all the settings, modify them, and probably update our firmware to the latest version. But in order to do this, we need to connect our drone to the battery. And next, what we are going to do, we are going to select port. And if everything is fine, and if you already have Betafly on your flight controller, you will have see something like this here. So in my case, we have port COM3, and I can click connect. So it's read information about all 4 ESCs that I have on motor controller board, and I can read parameters of them. So you can see that for every ESC, we have some set of parameters. Prior to go deeply into them, we first of all would like to update firmware. So what I'm going to do, I'm going to flash firmware here, and I'm going to pick probably the latest version, in my case 2.18. Apply, so we are going to select all ESCs. We have one board, but 4 ESCs inside, and we are going to click Start Flash. So it's flashing first ESCs. Done. Now we are editing ESC number 1 and flashing another one. And we flashed all 4 ESCs successfully. You can see now we have version 2.18. And here we can potentially change motor direction, but we don't know how we are spinning right now, so we'll do it probably from the Betafly configurator, but a little bit later. And now we would like to modify some parameters. So first of all, we are going to pick protocol by default. By default, we are going to use G-Short protocol. G-Short protocol probably is the most advanced one. Usually like 4-5 years ago, even more, 8 years ago, we used PWM and primarily sent information to motors about how to rotate them. But motors are different. Yeah, depends on the situation, depends on some parameters of each motor. They could rotate a little bit differently. And it means that we needed to calibrate our ESCs in order to compensate all this difference between the motors to make sure that if, for example, we are going to go straight ahead or just up, all the motors should be rotated equally in equal way, at least the same number of rotations, etc. Thanks to G-Short, we don't need calibrate ESCs anymore. G-Short allows us to automatically adjust all needed parameters in ESC and make all this calibration stuff automatically. So thanks to cable, for example, from motor controller to flight controller, we can not just send information to the motor controller about how to rotate motors, but we can get information about how our motors are rotating right now. So we have even bidirectional G-Short. It's like another topic for another lecture. But as for now, we need to use G-Short. We can leave, in fact, empty value and set up G-Short parameters from the Betafly or from any other
software from Mission Planner, for example. But as for now, we are going to use it here. Next parameter that we are going to change is PWM. PWM, it's a frequency that motor controller is going to use in order to control the motor itself. So how often is going to modify, for example, current that motor consume. And in fact, 24, 48 kilohertz, it's not biggest, but good enough number, especially for 10-inch drone. And we don't want probably variable. Here, variable allows motor controller to adjust this parameter, depends on the situation. But we would like to have it fixed to make sure that we definitely know what is going on to our motors. And we can leave 24 kilohertz, or we can use 48 kilohertz for these ESCs. I prefer to use 24. I found that in this case, our ESC is not going to be so hot and temperature is going to be good enough in order to even fly in hot weather, and I'm going to leave 24. The second important parameter is kV of the motor. In our case, we are using 900 kVs motors, and we have to put it here. Very important parameter, because by default you saw that it was 2200, and your motor controller will not manage motors properly if you leave it 2200. So 900 kVs is something that we have for our motors. Yes, we can check number of poles. The most of the motors, at least for these drones, we have 14 poles, and you can find this information in the motor specification, and for our motors is true as well. So we have motor poles here. It's something that we are going to leave as is. Very important to check temperature limit. I would recommend to set up 120, 140, because if you, at least for initial testing, because if you fly not too far, just a little bit, and you can see that your drone suddenly fall because your motor controller reached 120, it means that it will be much higher temperature if you fly more time, or if you start doing some loops and do some stuff that will potentially send more current to motor and allow. So that's why I would prefer to set 120. In fact, once you can see that your drone is flying well, you can potentially disable it. You can see that by default it was disabled, but pay attention, because I bought many of these motor controllers before, and for some of them it was a value like 30 something. And it means that your drone will fall probably right away once you just launch it. So that's why always make sure that temperature limit you is in a value that satisfy your needs. And in my case, I'm going to leave 120. And current limit, we are not very interested in current limit. And all other stuff, like definitely don't switch on sinusoidal startup. We don't need this, especially for this kind of drone. It's works better for ground robots like crawlers and etc. We have some servo settings here, usually default starting from 1000 up to 2000. We are not going to modify here anything, and what we need to do, we just need to save all the settings that we just modified. So I'm going to click Save. And you can see that all settings were successfully applied to all 4 ESCs. Now I can disconnect. So let's close. Okay, we can leave this website as for now, but let's find better file configurator. And let's try to connect our drone. And we still have our battery here. So we're not going to detach it because we would like to see if our motors are operating fine. So what I'm going to do, I'm going to open motors tab here. And you can see that we have 4 motors, and Betafly by default has a rotation of the motors that are moving towards the camera. In this case, I am going to modify this rotation. I'm going to run my drone, then it will rotate towards the center of the drone rather than to the camera. It helps if you are working in windy, rainy condition, if you are trying to even start your drone from grass, so lots of garbage can go towards your camera and you will not be able to see where to fly. So I'm going to leave like this. I am going to try to enable G-Shot 300 should be good enough. And as for now, we'll need to see if we really can rotate all these motors as we decide to do. So first of all, I will save and reboot. And now I would like to check real motor direction that motor have and see if it satisfies my desired motor direction. So I'm going to click motor direction button. And if suddenly something don't work and you can see that your motors are not spinning, just disconnect your drone from the computer and from the battery and connect again. It's happening from time to time that suddenly, especially after you update firmware, you need to power off your drone first, removing all the power even from the flight controller and connect it once again. So I'm going to do it individually, one by one, and let's click motor 1. Motor 1 is turning into a direction that I don't need in fact, so it's like opposite direction to my desired position, so I'm going to click reverse. And let's see. And now it's going into the right direction. Motor 2, let's see. Motor 2 moving to the wrong direction as well. I will click reverse. No, it should be normal. Okay, now it's good. Motor 3, pay attention that it can damage your fingers. Motor 3 has a right direction. Yeah. And motor 4, we need to reverse. Okay, now it looks fine. Now we can close. We can test all the motors once again, just enable them and start all of them slowly to make sure that all of them are moving to this direction, towards to the center. Okay, everything works fine and we will not return to the motors later. In fact, we will. We can potentially enable ESC sensor over a separate wire as well because we have telemetry wire for this stuff. And we can do it right now. We can go into ports, and for OART8 is something that we have for this flight controller. We will pick ESC as a sensor input. So our ESC send information about motors to port number 8, UART8, and we can save and reboot. And now we can go to motors again, and you can see now ESC sensor had been selected. So our flight controller will take additional configuration about motors, about current, and all other stuff. It's more like telemetry. That's all. And now, since we can see that all our motors works fine, and we can potentially fly, we have to add camera, we have to add VTX, and we have to add our Express LRS receiver. I will disconnect my drone. I will detach the battery and detach the drone from the computer, and we'll start adding all required components here.